Hi, Jeff. Hi to Chicago. All right, now we are also starting our live stream. Oh, hi, Frank. Hi to Sydney. All right, we are now also live on YouTube and LinkedIn Live. So welcome to everybody joining us from there as well. We're just going to give everybody another minute to join, and then we're going to get started.
Hey everyone.
Hi, Mark.
Okay, thanks. I really appreciate sharing the URLs.
All
All
right,
right,
we are all here, so it's time to get started.
we're all
Uh,
here. Okay, I just wanted to check, Adrian Bala, you okay on with the points where we're switching on the slides?
Yes,
The
Mark.
ones mentioned yesterday in the okay,
Yep, on the slide.
it's
Yeah.
back. Okay, sounds good.
all right.
All right.
Great. Thank you, Mark, and welcome to our panelists, and welcome to everybody joining us on this live webinar as well. My name is Tomasz, and I'm an ecosystem manager at LF Decentralized Trust, and today I'm going to have a chance to take you to some housekeeping and also introduce our panelists. So first, I would like to emphasize that everybody is welcome in our community, and we strive to create a safe and welcoming environment for everyone. So please follow our code of conduct when interacting with each other on this webinar and in the broader community as well. You can find our code of conduct on our website and on our wiki as well. All of the LF Decentralized Trust webinars are held under the LF antitrust policy, and you can find the antitrust policy on our website and on our wiki. This session is being recorded, and you'll be able to rewatch it on our webinar library as well as on our YouTube channel. And if you're going to go to our webinar library, you can also find the slides that will be shared today for download. Now, we also encourage these webinars to be very interactive. So the more active you are, the better experience for everyone. So please feel free to raise your hand, get unmuted, and speak up. You can also use the chat button or Q&A button to ask your questions there, and the panelists will get to them. If you're watching this on YouTube or LinkedIn Live, you're also welcome to use the chat button or comment section to ask your questions, and I will relay your questions to the panelists. Now, without further ado, I would like to introduce our great panelists for today. Mark Rakmilevic, who's a Group VP of Product Management and Development at Oracle. Bala Velanki, who's a Director of High Availability and Emerging Technologies in Oracle. And Adrian Ross, a Software Engineer at Oracle. We're very much looking to this great presentation. And dear panelists, over to you.
All right, thanks so much. Let me share my deck. Make sure I can share it properly.
Okay. Can you try to do it again, Mark? I just...
Yep.
There we go.
All right, great. All right, thanks for the introduction, Tomasz. We are really excited to be here for this webinar on self-sovereign identity, leveraging Hyperledger Fabric, and creating a decentralized identity solution that combines Hyperledger Fabric VDR with Credo Agent Framework and AnonCreds verifiable credentials in a privacy-preserving form. So we have today a couple colleagues, Bala Volanki, who is Director of Product Management in our team, and Adrian Ross, a lead software engineer for decentralized identity. And they're going to be helping me present this agenda. We'll start with a brief overview of Oracle blockchain, and the work we've been doing in this space, just to position kind of the foundation. Then we'll briefly discuss self-sovereign identity and some of the rationale and benefits that we see in leveraging this, and some of the basic sort of architectural principles involved. And then we'll dive into the self-sovereign identity architectures that we have been working on and the capabilities that we have developed in this area that include all of these components. We'll also have a demo to show you in a live demonstration what those capabilities look like in terms of issuing and verifying credentials in this ecosystem. And then finish with some summary slides and some time for Q&A as well. Of course, there is questions you can raise throughout, so please do so. My colleagues can try to respond online, or we can respond to some questions verbally as well at the end if they're general enough. All right, so let's get started. I'll start with sort of Oracle's vision for enterprise blockchain overall. We have actually been in the space for over 6 years now. We've launched our blockchain platform in 2018 with a vision of providing capabilities for rapid development of business and organizational networks. The idea really to focus on those kind of enterprise consortiums, if you will, where our customers can significantly optimize existing networks or create new ones, leveraging trusted transactions in a consensus-like DLT environment, while maintaining single source of truth, obviously, to share the data between various independent parties without requiring intermediaries. Our focus has been to make blockchain adoption both easy and quick for enterprises. There is a lot of complex technology. The stack is pretty deep and requires a fair amount of work to pull together and really make it enterprise ready. So what we focused on is creating an out-of-the-box production-grade platform that meets IT requirements in companies and government organizations, that provides reliability, security, scalability, either in a cloud offering, blockchain as a service, or as a platform for on-premises deployment. Provide development toolings that make it easier for enterprise developers to adopt this technology, low-code tools that help to generate smart contracts, for example, and go beyond that with some areas where we have pre-built solutions for business users, so they don't necessarily have to do a lot of development work on top of the blockchain platform, but can leverage some of the pre-built components and capabilities that we provide. So our blockchain platform is based on Hyperledger Fabric. We have been a close participant of the Fabric community for a long time. And we essentially created an offering that provides blockchain as a service with Fabric peer nodes, ordering service, membership service for identity management. And we've enriched it with capabilities for operations management and tooling that Oracle provides, ability to develop solutions that include API gateway for REST APIs to invoke smart contract transactions and also manage the platform through the REST APIs, as well as subscribe to events and publish callbacks, if you will, related to those events. And this is how we integrate with various applications that customers might have as on-premises or cloud. We've also created low-code development tool called Blockchain App Builder, which allows us to generate automatically smart contracts for a variety of use cases. You could have a generic smart contract or some specific ones for tokenization requirements with different types of tokens, fungible, non-fungible tokens. Lately, we've added confidential payment support. And so all of this infrastructure is available both in the cloud, as well as we have what we call OBP Enterprise Edition that supports that. Interoperates with other Fabric nodes, so multi-cloud, multi-vendor environment. Integrates with Oracle database for a variety of visualizations, analytics, that feeds the data from the ledger in real time, and various applications, of course. There is more details on the features. I'm not going to go into details of that. But in terms of the development tooling, which we are using as part of the solution, this is a low-code tool called Blockchain App Builder. It allows you to generate the chain code or smart contract project encode from a specification file that maps out the particular data model and the business requirements. Once it's generated, you can extend it with custom methods. So we generate in source code, the JavaScript or Go. You can extend it with custom methods. You can deploy it locally for testing. And once you've tested, you can package and deploy it on the Oracle blockchain platform nodes on premises in the cloud. We also generate the APIs that you can deploy in API gateway. So it's fully wrapped with APIs specific to each chain code. And we also generate Postman collection for testing that you can deploy and start testing those APIs right away. You can generate smart contracts based on a custom description, or you can use some of our templates relevant to different types of tokenization. So TTF chain codes, for example, a token taxonomy framework standard for ERC20 and the like, or directly ERC721 or 1155 NFT standards as well. Those are some of the templates that we support. We have also created a new edition of this platform called Digital Assets Edition. And this one is built to support a variety of tokenization requirements in decentralized finance, traditional finance, real-world assets, etc. Allows you to leverage customized specifications to auto-generate and deploy smart contracts. It is built-in role-based access control, compliance policies. It supports things like central bank digital currencies, deposit tokens, NFTs, whole and fractional. And we've been adding support for unified ledger architectures that are becoming prevalent in sort of multi-asset, multi-ledger financial markets. We've been rated, sorry, let me go back, rated pretty well by Juniper Research on top of the leaderboard based on some of this innovation and a lot of customer projects and deployments that we have done across financial industry, public sector, in a retail space, manufacturing, supply chain, trade and logistics, and variety of kind of Web3 NFT spaces. So there's been a lot of really interesting use cases over the years. We have an ebook where some of them are described. I would encourage you to follow that up again. But one of the areas we have seen specifically is around decentralized identity and verifiable credentials. And this is what we're going to be focusing on today. I'll just mention in passing that we've also been rated by Government Blockchain Association in the Blockchain Maturity Model Assessment, one of the few enterprise or blockchain platforms to pass that level of assessment. And the reason I'm mentioning this is because for governments, this kind of ratings are important. And decentralized identity is a topic that we increasingly see a subject of discussions and requirements at various government solutions and government organizations, particularly most recently in the EU. We have seen an emergence of very strong decentralized identity movement across the European Union, and a number of countries have specific requirements they're trying to meet in that space in 2025, 2026 timeframe, as well as rest of the world as well. So with that, let me go into the sort of the introduction of self-sovereign identity. There is, traditional identity systems out there today that we all know, right? Familiar with, we get passports, birth certificates, driver's licenses from DMV, student IDs. Banks, of course, maintain identity when you log into your account. Employers have identity both in the HR systems and identity and access management. You can have professional licenses issued by the states, insurance coverage, some of the examples where typically you have a central identity and in some cases federated identity, where your particular access from a third-party environment is federated to another entity. There are a lot of challenges and concerns related to using those credentials online. So sometimes you have to upload an image of an identity document. That's pretty risky. For a number of reasons, not the least of which is, while the document itself, maybe the image can be verified, it's not easy to link it with the person who's actually doing the uploading, right? If somebody has access to take a picture of your documents, of your identity documents, they could be pretending to be you uploading those documents, and there is no way really for the system to check whether the person who uploaded the passport, let's say checking in for airline flight or something like that, is the right person. Sometimes documents could be forged as well, and unless the verifier or relying party, as we call them usually, connects to the issuer's specific APIs to verify, the document could be fraudulent. Of course, when the issuer connects to when the verifier connects to the issuer's APIs, they have to identify themselves. Typically, the issuer can then track where your identity is being used and so on. And, that obviously defeats kind of a lot of requirements around privacy. Also, when you share those credentials, you share pretty much the full information, like, a copy of your driver's license, image, or passport. Might have a lot of information that's not particularly relevant to the verifier specific needs, but you have to share the entire document. You can't really selectively share specific, items or specific attributes. So all of these concerns, right, lead to this concept of self-sovereign identity, where you essentially have, issuers being able to provide the identifying information to a holder who can then present it to the verifier on their own. So user can control who they share the data with, when they share it. They can combine multiple credentials for the verifier if necessary. But in this kind of environment, the holders can preserve their privacy. There is no identity store at each of the issuers that can be breached. You have to really breach a whole bunch of holders to get anything useful, which is not practical. So there is no central point of failure, central point of breaching, if you will. And instead, the holder can minimize the data they're sharing just to the specific thing. So the way that this generally works is that you have multiple issuers that the holder can request credentials from, maintained in their wallet. Different verifiers can request a proof of certain claims that are within those credentials. The wallet will then combine the claims, maybe from multiple credentials or from a single credential, generate and present the proof, which the verifier can then validate without having to contact the issuer, because those proofs, if you will, include the signatures of the issuers and the signatures of the credential holder who's presenting them. This is kind of the model that has been generally popularized by W3C, and there is a lot of other emerging standards and foundations, DIF, OpenID, Trust over IP, TRKP protocol most recently, and so on, that are used in this space. A lot of benefits, obviously, if you compare the traditional identity management and verification system with decentralized identity. In the traditional environments, you depend on centralized authorities, central data storage, which can be vulnerable to breaches. You have to deal with this mapping from physical to digital, and so that creates a risk of forgery. They are often siloed. Integration could be extensive and expensive. And the issuer, because they have to participate in the verification process, can track your behavior as well, who you're going to for different verification for different sites, what have you. With decentralized identities, the control is in the hands of individual participants, right? They can determine whether they're going to share, when they're going to share, and so on, and control the presentation. Because it's all decentralized, it's really impossible to breach. Users have privacy, but also verifiers have privacy, because, again, they don't have to reference back to the issuers. The credentials are all based on cryptographically verifiable signatures. It's also instantly verifiable, right? You don't have to wait for a response from somebody. So they can create immediate trust. They can be interoperable because the schemas can be persisted on a shared ledger. Because you have those sort of built-in privacy, users are more likely to use those particular environments. So there are sort of three key conceptual foundations, if you will, of decentralized identity. Verifiable data registries, VDRs, which is basically a platform, not always, but usually a blockchain, which is shared amongst a number of participating organizations. If it's a permission blockchain, it could be public blockchain, and it creates an immutable record of the information that persisted. Now, VDR doesn't have any private data or verification claims. It only has a public key information that's necessary and the methods necessary to verify the credential. It also has schema definitions for the credentials and so on. You have decentralized identifiers, that are verifiable through the public key. Those identifiers are created by an individual, or it could be an organization, could be even related to a device, so we call it an entity in general. And it's anchored to VDR through the use of DID documents. Those documents is where you essentially maintain the verifiability methods, and you have ability to verify through the public keys. And then the third piece is verifiable credentials. So this basically groups of claims that are issued as credentials that are cryptographically verifiable. They're issued by a particular authority. Again, it could be a government entity, it could be a university, employer, any other kind of organization that needs to issue credentials. They're signed by the DID of that issuer organization and can be verified that it came from a trusted party. And then those credentials have claims which can be presented either individually or combined with other claims and presented to verifiers by the holder. In this model, you essentially have what we call a triangle of trust, right? So the issuer, holder, and verifier. This flow is described basically as a verifiable credential data model in W3C. The issuer will issue the credential to the holder. There is an exchange typically using DIDCOM protocols, but not always. We've recently had discussions with customers interested in using OpenID flows. So you could have DIDCOM or no OpenID flows. The holder can work with multiple issuers, of course. We're just showing a single one here. The holder can then present those credentials on request to the verifier. The verifier can refer to the verifiable data registry for the credential schema and definition, and for the verification methods using public keys that are involved, right? And those schemas and credential definitions and the DIDs would be written by the issuer to begin with, right? When they issue a credential, before they issue a credential even. So all of this can be used as part of the verifier processing of the credential. And there would be a set of verification steps that they take. Now, typically, these communications happen using what's called SSI agents that represent each participant in this flow and orchestrate the flow of the protocols. Now you think, okay, this is a fairly straightforward method. In reality, it can be a little bit more complicated. There is a set of flows around credential exchange, setting up the connection, and so on, as well as presentation exchange and connection between holder and verifier. Verifiers need to have a lot of capabilities associated with the verification of the presented credentials, different formats for credentials, etc. You need to have the verifiable data registry, which maintains decentralized identifier, DIDCOMs, schema definitions. There is also a need to be able to revoke credentials after they've been issued. So there is a revocation registry, trust registry to determine who is the trusted issuer, and many other things, of course. So this can be a fairly complex environment to deploy, and we'll show you how we've actually implemented it using the Hyperledger Fabric and related technology stack. But just before that, I wanted to touch a little bit on why we think that implementing subsolvent identity with Hyperledger Fabric makes a lot of sense. As I mentioned, we have been in the space for almost 7 years now, and we feel that there's a lot of customers out there, particularly using Hyperledger Fabric. It's a very versatile platform. We have a few hundred customers, and in the industry in general, there are thousands of customers, organizations using Hyperledger Fabric. So if they have a need for a decentralized identity solution, why should they worry about deploying yet another different blockchain when they already have a perfectly good blockchain they're operating, they're accustomed to, it's running their business day to day? It seems like makes a lot of sense to just use the ledger technology you already have and build on it. The other factor that permission blockchain architectures that Fabric supports that allows different nodes to be authorized and participate together in a consortium deployment model actually fits pretty well with the trust registry anti-RKP model. It provides controlled and secure access. So the organizations that are joining are, controlled, and there is an agreement from the consortium that they can join. There is existing collaboration across consortium members. So, in this particular diagram, you see kind of a healthcare model where there is a lot of participants. There is a lab, a pharmacy, physician, hospital, etc. Patient, all of them can participate. So it makes, kind of sense to be able to, in, let's say, healthcare use cases where you need decentralized identity. And in fact, healthcare is one of the more frequent verticals where we see this come up. If you're already using, let's say, Hyperledger Fabric-based deployment, to be able to layer on top of this. The other fact is that, Hyperledger Fabric has been built for scalability and performance, and so it provides a very efficient architecture with ability to run, multiple peer nodes, ordering nodes, membership nodes, etc., that you need for high throughput use cases to be able to parallelize a lot of the processing. For example, it's frequently used in central bank digital currency, CBDC deployments. And we know that SSI is actually of quite strong interest there because it can help protect privacy, which is key particularly in retail CBDCs. So with this preamble, I guess, let me pass it on to Bala Valanki to talk about Oracle's SSI architecture and capabilities.
Thank you, Mark.
Bala, just say next when you want me to move.
Yeah, sure. So looking at the implementation of SSIs and Indy and Aries that are there, we started looking at building solutions using Oracle blockchain platform. And this mainly we focused on building solutions for verifiable credentials and access management based on certain specific cryptography and privacy standards. In the whole VDR, what we are using in building this, implementing the solution, a decentralized SSI is on. We use OBP as a VDR. And we also offer, we also provide agent services for each ecosystem of the participants who has access to the VDR, where they can exchange credentials and other data with different participants. So in the participants in this case can be issuers, holders, and verifiers, and all of this data will be given access through the agents VOF and can be stored in VDR in this case. We also provide API services that can easily integrate with the identity management and external systems. Mainly, we provide the APIs and DID services for the verifiable credentials lifecycle. There are a lot of SDKs that we are using in the solution for issuing and verifying the credentials for the holder, and all of these SDKs are provided. And we provide sample portals for issuer and verifier to just demonstrate the capabilities. We also have samples of a holder wallet app, which Adrian will be going and discussing and just showing you in a demo in this case. Next slide, Mark. Our solution, our Oracle's SSI implementation was mainly we used TOIP's technology stack as a guide to implement our solutions. Looking at different layers and components. If you look at the layer one, what we are trying to do is having Oracle as a VDR, which has Fabric chain codes and for DID at the DIDs and schema registries and revocation registries and trust registries that are deployed as chain codes in this scenario for layer one. And layer two, we adopted the Credo version of Credo version of the framework and started building APIs and SDKs that are going to interact with Oracle's blockchain platform as a VDR. In this case, we also looked at Hyperledger and AnonCreds, and we support the verifiable credential formats for privacy, protecting ZKP proofs, etc. in this case. So, and coming on to layer four, we are pursuing multiple partners and ISV and SI solutions to build solutions on top of our platform, where they can use the Credo and AnonCreds ZKP protecting formats and JSON LDs, etc., which can talk to Oracle blockchain platform as a VDR in this case. These are mainly the 4 layers where Oracle is looking at, Oracle's SSI, SSI implementation will provide capabilities for you to build the SSI, will build SSI, SSI solutions for healthcare or any other solution stuff. Next one. So our main architecture, if you look at it, basically at the bottom, Oracle Blockchain Platform, what we're doing here is just providing the VDR that is built on Oracle Blockchain Platform, and have a collection of smart contracts for DEDs and building credential schemas, and also supporting the revocation registries. And we deployed all the agents that are there as containers on the Kubernetes cluster, with which have API endpoints to communicating it with each other via the WebSockets. And there are multiple VC models we looked at, and we support the W3C standard, and also Hyperledger AnonCreds, which is using zero knowledge proofs for the stronger privacy preservation. We also provide some sample portals sample portals for issuer and verifier, and also some components, web components that support common agent capabilities such as issuer processes and verifier processes. Our solution is designed to integrate with Oracle's IAM and applications through the API services, where we provide plugins to all of these for the plugin, and also APIs for registering, resolving the DIDs and communicating with the IAM platform. We also have we also provide the APIs for issuance and verification of verifiable credentials using a REST API implementation. So going on to the next one, actually, here is the higher version of what Hyperledger Fabric-based VDR would look like, which our Oracle Blockchain Platform is built on. And you see the REST events and REST APIs that we provide for each component. In this case, basically, you can see the DIDs, which all the issuers, holders, DIDs, and docs and public keys are stored on the Oracle Blockchain Platform as a registry. And also we have credential schemas that if you come up with a new one, we provide automated the capabilities to just go and create your own credential schema and register, and start exchanging the verified credentials between all the participants. The final thing is the revocation registry is the one which we also support. These are all provided as a smart contract APIs, which we offer callbacks and events via a REST proxy or a REST API gateway, you can call it, which is built on Oracle Blockchain, which is built in Oracle Blockchain Platform. We support we support VDR that includes multiple contracts and anchoring self-designed to distributed ledger technologies. Mainly our technologies support the BYOKs and DID URIs and URL resolutions for multiple formats like CIBOR, JSON, and JSON LD. So finally, we have a verifiable history of the snapshot on the VDR, where you can go and look at this verifiable timestamps and hash links that are supported in this case. Next one more. So the trust registry is the one where decentralized the LFDT was looking at from our last community calls. We looked at multiple solutions for this trust registry to support the issuer trust models that are there existing in different formats. But after looking at this trust registry query protocol, we started building solutions on this trust registry, where Oracle Blockchain Platform will be used for recording the authority statements between the authority ID and the entity ID, providing assertions of different types. In this case, you can see the authorization, delegation, propagation, and description, which is supported. These authority statements mainly are also supported by TRQPR. We take the basic spec from TRQP and we support it on Oracle Blockchain Platform Trust Registry in this case. All these are provided as APIs, and you can see one of them based on the TRQP. You can answer questions like, is hospital X authorized to issue health credential to Y in ecosystem Z? Similarly, with some other examples like company X giving a verifiable employment credential to Y in ecosystems. See, all these are examples of how what we support as authorized statements in authority statements in the trust registry of Oracle blockchain platform. Provide all these as APIs. Now I'm going to hand over to Adrian from here. I think Adrian, you can hear me, and from you can. Mark will be guiding you. Thank you.
Thanks, Bala. So if we look at our solution and ecosystem, as Mark and Bala kind of pointed out, we have our chain codes that are deployed on the Oracle blockchain platform at the bottom of the stack. But moving more towards the end user as well as the users of the ecosystem, we've developed a peer-to-peer network on top of that called our agent containers that are deployed on Kubernetes. And on top of that is an SDK. So each agent has a REST API interface as well as a WebSocket interface for mediator connections, as well as an SDK to call and extend the services to external services outside of the SSI framework. And the web portal is also built on these SDKs. And so I think it's kind of a testament to how adaptable they can be. I think next slide. So why Hyperledger and AnonCreds? We kind of can look at the different types of credential formats. You have MDoc, you have JSON-LD, you have SDJOT, and AnonCreds. And while all are supported out of the box in Credo, AnonCreds really takes the win for being the most privacy preserving. It's based on Kamishka Leshkansky signatures and has blind signatures for issuance. The holder obtains the signed credential and it's linked to something known as a link secret, and this binds the credentials together for later presentation of the credential. It uses zero knowledge proofs for many of the different aspects. Some of them can be non-disclosing, not disclosing the underlying value. Some of those could be predicate proofs. There's a whole assortment of different types of proofs that can be used with AnonCreds, which you don't get in the other credential formats, even though there's some work to get there with ZK circuits. But AnonCreds really checks all the boxes. Schemas standardize within the network, and in our implementation, it's standardized within the permission network, but we're working on kind of interoperability between multiple permission networks. And then credential definitions, which I can get into a little bit more during the demo, is really where we can enable revocation also with zero knowledge proof functionality. For the AnonCreds flow, before we get into the demo, there's some setup that needs to happen. So I was talking about these two objects, the schema and the credential definition. They're both necessary for an AnonCreds credential. This is slightly different from what you can or what you need for JSON-LD, the standard W3C verifiable credential format, but you need to publish these public objects somewhere. The credentials themselves are not published on the blockchain network, of course, because they contain personal identifiable information. But the schemas and the public keys are that the issuer uses. So the issuer first publishes these objects, and then from there, the holder can pull them in, and there's some communication that happens between the issuer and the holder on the credential offer. And so we kind of move into the issuance data flow where the holder reads from the VDR and the issuer issues schemas based on that credential definition in the VDR. And they come to agree that, okay, the credential that's issued contains everything that's in the credential definition. So it's not like the issuer is offering them an invalid credential. So there's guarantees on the holder side. And then for the issuer side, there's guarantees because the holder sends over a blinded link secret. So the holder never discloses this secret value which binds these credentials together. So there's it's almost impossible for correlation between the issuer and the verifiers later on. This uses DIDCOM v1 in our implementation, and we're looking to migrate to DIDCOM v2 pretty soon. And yeah, it also uses HTTP or HTTPS transports. And then for the presentation flow, which is between the verifier and the holder, so the holder takes these different credentials that they were issued and can bundle them in different ways. They can take the claims out of the credentials and put them into a presentation. So the credentials themselves are not one-to-one with the presentations, but they can be mixed and matched. And this allows for, let's say, the case where you get multiple credentials from two different issuers, but you just want a single presentation guaranteeing that you have claims from either one, maybe just a subset of one credential and a subset in another. And presentation success right now is just measured through a single is valid factor. This is something that's part of Credo, but we hope to expand that as well. So next slide. For the AnonCreds implementation, I was kind of talking this difference between the private objects and the public objects. All we really need on the VDR is the public objects, and there's usually a private counterpart to each one. So on OBP, Oracle Blockchain Platform now, as soon as the private credential definition is created on the issuer, the public one is created on the VDR using chain codes and is resolvable for all the different players here, the holder and the verifier. For the revocation registry, that's still work in progress. It's the same deal. There's some private aspects where the private keys correlate to the public aspects, and so only the issuer has control over revocation entries that can be added to the revocation registry. For the schema, any schema can be used by additional issuers. So a schema, like I said before, is just kind of an interoperability between the private network or the permission network that you can create multiple public credential definitions for each schema. You can kind of envision public credential definitions as like a batch of credentials that are going to be issued that are already connected or slated for a revocation registry, while schemas can be reused and they're not expected to be changed that much within the network. We can move on to next. So how do we expose this from the agent to outside of SSI infrastructure? Well, Credo has a REST API package. It's slightly outdated, so we took that and cleaned it up a bit, as well as expanded its capabilities. You can import your own keys. That's the bring your own keys aspect to it. You can manage your public decentralized identifiers on the network a little bit more than you can with DidWebs. You can manage the credential schemas, very similar to how Indy used to do it, but there's some additional aspects there as well. For instance, I can see all the other credential definitions on the network using the REST API call, given that I have the permissions to do it. And yeah, you can also connect to other agents over peer-to-peer protocols. DIDCOM is what we're going to be showing in this demo, but we also have OpenIDC for VP and OpenIDC for verifiable credential issuance capabilities in the pipeline. And over DIDCOM, you can do issuing and receiving of the credentials, as well as then offering verifying of the presentations. And each of the agents has those capabilities. They can be upgraded to mediator connections, where it's the agent just relaying messages for you, as well as this mode called multi-tenant mode, where you can have multiple connections to a single agent instance. Next slide. This is kind of reiteration, but it's built for interoperability. So our web portals, as well as our REST API or REST SDK, has very little dependencies. So Credo or kind of opposed to many of the implementations that I've seen that use Credo as a direct dependency, even for the SDKs, as well as like any web portals or React-based interfaces. Credo has to be a direct dependency, but we wanted to avoid that just due to how Credo is implementing some things with integrating AnonCreds directly from Rust, which is completely fine for the agent. But when you're talking about external services, then you have to consider the runtimes, all these other aspects, the versions of the software that you're using. And so we thought it would be best to eliminate those dependencies and just have it as light as possible. And so that's what you'll be seeing in the web portal, where like there's almost zero local state in the web portal. All of the state is persisted in the agent service. And the agent service persists this state not even necessarily in Credo, but mostly in the OpenWallet Foundation AskR wallet. And so in the AskR wallet, we're working with a MySQL version, which we have yet to make public or really do anything with. But it kind of is different than the Postgres solution that is used by most people. The scale of it is about the same. So Credo is still working towards implementing direct database connection for non-key management service capabilities. Next slide. And so now onto the demo. We're going to be showing a couple different capabilities. We have 3 different players, kind of that triangle of trust that you have been seeing. So we're going to register an issuer and their DID on the Oracle blockchain platform. You'll be able to see that, as well as the issuing of the credential between the issuer and the holder. So the issuer is first going to do that setup flow for AnonCreds, where it's going to publish the schema and the credential definition to the AnonCreds registry on the Oracle blockchain platform. And then it's going to create an invitation, a DIDCOM invitation, as well as connection with the holder, and they're going to establish that peer-to-peer connection. Over that connection, the issuer is going to send a credential offer, and there's going to be a little ceremony there where the holder accepts it, and then the issuer signs it, and then issues the actual verifiable credential. And then for the verifying part, it's going to be fairly similar. The verifier is going to create an invitation, and the holder is going to accept it. The verifier is going to then query the verifiable data registry to get or to pull in the different credential definitions. And then it's going to request a presentation from that. The holder does this wallet matching in the Credo agent called the wallet query language, where it matches the most suitable claims to the presentation request. If there aren't any, it fails right there. But if it does succeed, then it constructs a verifiable presentation where it selects those claims from one or more credentials and sends them back to the verifier. The verifier validates the issuer's DID from the verifiable data registry, and it validates the signatures as well. The reason that the holder's DID does not need to be on the verifiable data registry is that there's already that peer-to-peer communication, and it can already guarantee that the cryptographic material is valid. So yeah, moving on to the demo.
Let me stop sharing here, Adrian, so you can share.
Thanks.
By the way, just as we get the demo, just to encourage folks, please, submit questions. There is Q&A buttons there at the bottom of the Zoom, so you can post questions there, and we'll be able to answer a few at the end.
Awesome. So I'm already logged in here to an issuer and a holder. And first off, we're going to create that cryptographic material necessary for AnonCreds. So I'm going to go to the identifiers part where we can see all of our DID peers. I already did a peer-to-peer connection just for testing this morning, but we're going to generate a key pair. You can bring your own key right there, but just for testing purposes, we'll generate it on the dashboard, and you would save your private key from there. And then you would create your DID from this. because this is a permissioned test network, I'm not that worried about the private key being leaked. But here we go. You're able to see the DID is resolved. We have our verification method, our assertion method for issuing credentials, as well as authentication onto the platform for proving control over the DID, as well as some resolution metadata. And you can add some additional services from there, but we're not going to cover that necessarily today. And then from there, we can go on to creating a schema. So we have this built-in templates that are just hard-coded that you can kind of base your template off, but this translates directly to an AnonCreds schema. So you can see here what that looks like. If I was to select the right DID, then it would actually be valid. But our use case today is going to be retail CBDC. So our issuer in this demo application is going to be a payment service provider, and they're going to issue almost like a wallet attestation to our holder, Alice, saying that they have a wallet with certain capabilities. And so we'll paste that in. And if we, oh, maybe I have to do from scratch here. Okay, well, we can type it in. So that's going to be our name and then account type. We're going to have an account number, of course, a bank name, which connects it to a traditional financial institution, bank routing code, a couple Boolean flags, has stablecoin access, and has foreign exchange access, as well as a transaction limit to showcase a predicate proof. And then we're going to select the issuer DID. We're going to issue this. And then this has issued it on the Oracle blockchain platform. And here's our attributes here. And now we're going to create our credential definition. So you can see revocation coming soon. And there's some additional metadata that we normally hook up. Just in this demo, it's not necessarily there, but in the credential definition state, you can see all that metadata. So it has its tag, has all these primary keys, allows for the master secret, the link secret, all this additional stuff. And so now we can create a peer-to-peer communication between the holder and the issuer. So I'm going to just create that. The connection can be ABC Payments.
In reality, you would have the holder probably scan the QR code, right? So on the
Yeah,
website
exactly.
or something. Yeah.
And you would just
copying that over.
Yeah, you would register it with the DID as like a service. And that could be like a multi-use invitation and connection. So there you can see the holder has already established the connection on its side. You can see the connection details. It already created a DID peer for that connection. And on the issuer side, it said it's completed as well. So now we're going to go into the issuing flow. Which is here in credentials. And in the issue credential view, we can see our schema that we created earlier. It grabs its details. Like I said, it doesn't hold state in this application, so it has to grab it almost every time. We can see our existing connection with Alice, which we're going to select. And then we're going to protect our bank name and bank routing code. So we're going to assume that that's private information that the holder does not want to share. But we're going to issue the credential with it first. But just for the verifying purposes later on, that's going to be our private information. So for account type, we can put this as retail. For account number, I have one here, which is just going to be a hash string. Bank name, let's say bank X. Bank routing code.
The
We'll
UK
say
sort code.
true. And then let's just say our transaction limit's already in the thousands to make it easier for predicate proofs. So I'm just going to say, or maybe like tens of thousands. So just 3. And you can add additional things like comments, select a protocol version, the auto accept. So now in the credential table, we can see that the holder has received it. And if we expand this a little bit more, you can see the attributes that are being issued, as well as the metadata and everything else. But we're just going to accept the offer. And yeah, now it has migrated to request sent. You can see the status of the credential through the credential lifecycle. The request has been received on the issuer side, which we're also going to accept. The credential has been issued, and then just have to give it a couple of seconds, but the credential has been received, same data, same view on the holder side. So that is it for the issuer, and now we're going to migrate over to the verifier. So I'm going to drag it over here. And for the verifier, we're also going to have to establish a connection. So a new connection between the verifier and the holder over DIDCOM. So we're going to do the same thing. Let's say this is a retail store.
Adrian, sorry to interrupt, but just to let you know, we're almost at time. We have a bit less than 5 minutes left.
Okay, I will go through this quickly then. So we're establishing the connection here. Just have to wait until it's refreshed.
In reality, right, in the real application, a lot of this will be hidden in the background, sort of, between the devices. We're just showing the more kind of explicit view of everything that happens here for developers who want to be able to actually track and understand the details of the communications and flows here. So the portals were built basically to simplify life for developers.
Exactly. And here you can pull in that credential definition that we had. It's grabbing the credential definition. You could see it's from the issuer. We're going to just import all the variables to make it quick. It's very similar to the credential issuance, but for this proof request, we're going to exclude the bank name and the bank routing code. We could add predicates, but just for time, I'm going to exclude it. But now we're just going to send that proof request. So the request has been received. We can see it on both sides.
So the holder's wallet now basically going to select the claims to respond to this, right? Okay.
Yeah, we can see the claims as well as some of the restrictions on there. That has to be from the credential definition. You could do this in all the same group, but
yeah.
So the presentation is sent, presentation is received, and we're going to accept it. It's done on this side, and it's passed and verified on this side, and then in the verifier details, you can see the underlying values, but obviously the bank the bank name and the bank ID has not been shared. So we're doing selective disclosure there. And yeah, that's it for the demo.
All right, great. So just to close off with a brief summary here, let me 1 second. I need to share. Share screen. Okay, so as we mentioned, basically, this is a self-sovereign solution that's built using Oracle Blockchain Platform as a Hyperledger Fabric VDR, on top of which we have the agent framework based on OpenWallet Foundation Credo with AnonCreds, Verifiable Credentials, and then the SDKs and the portals on top. It's running on a permission blockchain platform. There's a number of extensions that are based on this industry standards, of course. We have adopted them to this architecture, but integrated this together in a way that allows us to provide some flexibility in the APIs and protect the privacy. It's a headless, if you will, API-based platform, so you can integrate it into a variety of applications. The focus is on verifiable credentials that can be used across a number of different industries as well as in government applications. We're also beginning to look at some additional applications of decentralized identity, and particularly DDoS support as an authentication mechanism for potential integration with various Oracle identity management solutions and applications. We are looking at the initial scope of this, supporting all of those different standards, as well as specific credential formats, including W3C and AnonCreds, API protocols based on REST and WebSocket, and adding support for mobile wallets, the standard kind of sample-based bifold environment, and some third-party partner wallets integrating with this potentially. We're closely following the community roadmaps for AnonCreds V2 and for Credo. There is some really interesting things coming in AnonCreds with swappable signature schemes, with BBS Plus in particular, which looks to be very promising, more scalable verification mechanisms, and crypto agility that would make it easier to separate different cryptographic libraries. On Credo side, Adrian mentioned that the current verification status basically gives you just is valid. We're looking forward to more granular support, so you can verify specific claims and also do cross-schema support. So with that, we'll pause here, see if there's any questions, and also back to Thomas.
Yeah, thank you, Mark, Adrian, and Bala. We do have one question. We are sort of over the time, but let's take one. There are some questions popping up if you can see it.
In the Q&A panel or in the chat?
In the chat, yeah.
Oh, in the
Let's
chat.
take
Okay.
one question, and then we unfortunately have to wrap it up.
Sure. Yeah. Okay. Let me see the questions here in chat. All right. Let me see. So, okay, there are some comments from Stephen here. Great, Stephen. Yeah, happy to collaborate on this. So, I see a question here. Can issue a verifier have Oracle HLF node set up for them? Yes, certainly. We provide a managed service, and in Oracle Cloud, for example, in addition to Kubernetes, kind of on-premises, a third-party cloud deployment. So you can come and all of the nodes are set up through APIs. So it's very straightforward in an application solution, for example, to integrate those APIs to provision the nodes automatically. And then, for the issuers in particular, verifiers could be on shared infrastructure. Issuers might want to be on dedicated, nodes. But yeah, there is full API support to provision and manage the nodes automatically.
Great. Thank you so much. And apologies, we'll have to wrap it up. But for those of you whose question we didn't get to, please feel free to reach out to us or to Oracle team as well. So just to wrap everything up, first of all, thank you so much, panelists. Thank you, Mark, Adrian, and Bala, for this great talk. And thank you, everybody, for joining. And thank you to people that are joining us live on
Thank
YouTube
you, everybody.
and LinkedIn Live.
Thank you, guys.
As well. Now, before we go, I would also invite you to have a look at our LF Decentralized Trust event page for the more upcoming webinars, as well as the live events where we'll be present on. Please also visit our meetup page, also to find out more about the live events, as well as the online events that LF Decentralized Trust and our members will be at. Please join our Discord community. There's dedicated channels to a lot of projects that our panelists discussed today, Hyperledger Fabric, Indeed, and identity projects as well. And there's a lot of real-time interaction going on there. So you're welcome to join and ask your questions. Finally, if your organization is interested in joining LF Decentralized Trust, please email the ecosystem at lfdecentralizedtrust.org or follow the link on these slides. Again, thank you everybody for joining. Thank you to people watching later, and thank you again to our panelists. And until next time.
Yeah, and thanks to LFDT and Thomas.